And we are live. Hello, everyone. Welcome to Serverless Bhubaneswar. Welcome to a new session on building and deploying serverless .NET applications on AWS. So we are coming after a long break. Probably the last event which we had was in March, and we really regret that we couldn't, host more events of late. However, the situation has been pretty rough. So we're back, and we are coming back with a lot of sessions. And today we have our guest Amit, who is working as a senior developer advocate at AWS. So hello, Amit.
Hey, Ashirwad, how you doing?
I'm doing good. How about you?
Good, man. Hope things get back to normal. I'm itching to go out. Been a while doing all remote sessions.
True indeed. Even we plan to have some offline events, but the scenarios are not supportive enough to host offline events or in-person events. But let's finger crossed. You never know. So
Yeah,
Amit, the stage is
definitely.
yours.
Thank you. Thanks, Ashirwad. Let me quickly go ahead and share my screen. If you can just confirm that you can see my screen, and then I'll get the party started.
Sure.
You can see it?
Super excited. Yep. Ready to roll.
Okay. Great, wonderful, thank you. Thanks for the introduction, Ashirwad. This is Amit, been with AWS. Let's quickly just run through. Right now, my role is developer advocate, but I have pretty much been a solutions architect for the last 4.5 years. So learning the developer advocate role. Before this, I actually worked at Microsoft for close to a decade doing development and development consulting. I work out of New York, so I have a lot of fencer-oriented use cases. So I may bring in those conversations as we get along. So what do we talk today? .NET, right? I mean, .NET and AWS, many people say, really? Are they? Right? So we'll be talking about what tool sets we have for .NET on AWS, understand the integrations for .NET, understand a typical .NET application migrations, modernization journey to AWS. And today we have another lens, which is basically cover the serverless services. So we'll touch upon those. Along with this, I will have a good amount of demos. See, we are all developers, so we like to see things, then talk in the PowerPoint. So I'll try to keep it that way. Okay, great. And we also will touch at the end around DevSecOps services. So as you can see, I have good amount of content. So I will be running through, but if in case you have a pressing question, don't wait. You can put the questions. If not, I'll make sure I keep some time at the end to go through questions, Q&As. And we also have goodies and giveaways at the end, so stay tuned. Before tech, we need to talk about business, right? There has to be driver. What is the driving factor? Whenever enterprise customers I talk to, they say, hey, we want to go to the cloud. I'm like, great, why? Why do you want to go to the cloud? Sometimes it's a cost conversation. Sometimes it's the agility, nimbleness with which. So if you take FinServes, there is a large enterprise FinServes, 100-year-olds, and there is FinTech, which can innovate much faster because they are onto the newer architecture and leveraging the cloud native services. So these are the 5 pillars I feel that makes a difference. First is architectural patterns. So you will hear the term monolithic to microservices, event sourcing based pattern, decoupled architecture. The more you have, the ability to move faster, make the changes, it's better. The next is operating model, right? I mean, you have on-prem operating model, changing a firewall port takes weeks or 10 days, right? Whereas you go to cloud, you can actually automate that security group setting, and you can actually change it just by call via CLI or SDK. But you have to have a operating model in a way that it is very less undifferentiated heavy lifting. It's more automated. It's more proactive, right? The automation of CI/CD is another factor. Many customers want to go towards a nirvana of check-in or commit triggers a build, triggers stress, triggers deployment, triggers notification that, hey, it's all went perfectly. I still have to see a complete end-to-end without any gate. Most of the time, I see some kind of gate to make sure. So that's another area. The last two is basically management and governance. Just because you're going to cloud does not mean that management and governance goes away. You have to tag your resources. You have to, and cost becomes pretty big pillar with the cloud, right? So unless you have resources tagged properly, cross-charging is hard. Knowing which team is using which particular services or resources is very hard. So you have to have the right management and governance. Data management, another one. So what happens is basically customers and enterprise customers in particular are looking to create their own data lake, come up with APIs for data, and maybe there is a monetization strategy. The data that was sitting stale before may actually have value exposing via APIs, right? So there is a business driver, right? The organizations want to become more nimble. They want to move faster, and hence these are the set of pillars that make that difference. Okay, so now come to .NET on AWS. Is it today, yesterday, day before yesterday? No, it's been 13 plus years, right? Very quickly, if you see, 2008 we started supporting 2003, then moved to 2008, different Windows Server editions, moved to SQL Server, moved to .NET. I mean, if you typically take a Microsoft shop, you will have Windows, .NET, SQL, AD, right? And when you deploy an application, it's not just these. It also is authentication and authorization. It's also monitoring, tracing. So if you can see, we introduced X-ray again for tracing. We have integration for authentication, AD on AWS, managed directory services, right? So we went through the whole 9 yard, and modernizing .NET application is another area that we've been investing heavily. Last but not the least, last November, I think .NET 5 was released, and I'm happy to say that we were the first to actually support on AWS. So 13 plus years, what do you want to take away from this? There is a good amount of investment, and we are not stopping. We have continuous investment and newer things coming up. Tools. What do you want as a developer? Hey, Amit, do you have SDK? Hey, Amit, can you do something in Visual Studio? Hey, Amit, do you have some kind of templating, right? So what I'll do is I'll stop the PowerPoint slide as committed, and I'll start going inside Visual Studio. So here is my Visual Studio. What I'm going to do is I'm going to show you something that I have installed, and that is an extension. That extension is called AWS Toolkit for Visual Studio, right? We have it for 2017, 2019, and the previous edition of Visual Studio 2. Once you install this extension, you will see something called AWS Explorer. What is that? Basically, your services. So for folks who are absolutely new to AWS, just want to make sure that you sign up. Once you sign up, so I am gonna start in a private mode. Let's do it. Console, I am logging in, and this is the one I created for today. So I'm here, and I can manipulate the services here, right? As a developer, I do not like to actually go to the console. I would rather want to work inside Visual Studio. And the idea behind Explorer is that, so you can see all your resources right from Visual Studio, right? EC2 instances, RDS, S3, Lambda. I mean, we'll make those services very clear very soon. But you can see the resources, and not just see, you can actually manipulate. You can create, you can change. Let's see, EC2 instances. Here you go. Okay, I can do other operations. I can connect, right? So basically, the idea is you do not have to go out of Visual Studio. So you saw the resources, right? The second part is basically manipulating those services. So very quickly, I'm going to run through a sample which iterates the same set of bucket using the .NET SDK. So the drill, you do this drill for every service. The first drill that you do is you take a dependency on a NuGet package. So I'm going to go here, show you that. Okay, so if you do AWS SDK, we have it for every service, whichever service, so corresponding, that's the naming pattern. In this case, I have taken the dependency already for S3, right? You do an imports for two, S3 and S3 model, right? Now, very quickly, this is a pattern which will be applying for all the services. So Amazon.S3, Amazon.S3 model. So if it is EC2, Amazon.EC2, Amazon.EC2 model. If it is recognition, Amazon.recognition, Amazon.recognition.model. Okay, so that's the pattern. You create the client, and then you start calling the corresponding API. So let's quickly go in and see. Okay, let's go in. I created the client. what would you expect from a bucket? See, S3 is our scalable object storage. So you would think object storage, so copy, move, delete, right? So those kind of functions. Yeah, so the same thing, it's available. And you will see a pattern that there is a sync async. Like we've been familiar, you want to call and wait, or you want to call, have an async based async result callback, right? So you could do both the ways. So in this case, I'm going in and I am creating this list buckets, gives me a typed object, and I can iterate through the typed object and print it. Right? So the same thing that you saw on the console, right? The same thing that you saw on the Explorer. Let's go back again. Yeah. Right? And the same thing being iterated. And now you will have questions. Okay, Amit, so you have this console which has an account. How did this guy know that account? Very, very valid question. If you see here, there is called credentials. Right now, I have configured, I can actually configure it with other credentials also. In AWS, you create a user that's a permanent credential, or you could do federation, SSO based. So if you create a user, you will have access key ID and secret access key ID. And these two are used when you are calling. So you'll say, okay, you called an API for S3. How do I know what was passed? So let's do this. I will run a HTTP tracer, it's called Fiddler, and I will rerun the code that I showed you just now. So let's go in and run the same code again. So let's hope the demo gods are happy. Let's go in and run this. I want to, okay, create, yep. So this is the one which will call the, let's go to the Fiddler. Here you go. As you can see, this made the call. It's 200 means status is okay. In this case, it responded in an XML. By the way, one thing to note, the SDK simplifies the underlying serialization and deserialization. You do not need to know, like, is it JSON, is it XML, because it is doing that underlying plumbing for you. It understands the API, it understands the response type. So earlier versions of services had XML. Most of the newer services have JSON, but that's again abstracted from you. It's the SDK that takes care of it. Now here, if you see, there is authorization, and it has passed something called HMAC. So here is the access key. So there's nothing secret about it, but the secret key is which is secret. So it creates a HMAC signature and passes that. So the S3 API on the server side actually takes this, validates it, authorizes it, and that's where the permission flow happens. Okay, so we very quickly, what all things we did. We installed a extension, right? That's the extension. Once you install the extension, AWS Toolkit for Visual Studio, you see something called Explorer. And that can show you all the resources. You can manipulate them. Next is we actually use the SDK. In this case, I am using S3. Let's do another one. How about there is a service called Comprehend. It's a AI service. Given a text, it can actually find out sentiments. It can find out, let's do this. I will go ahead and let's stop this. Okay. I will remove this file to show you just another example. I'm calling a AI service. This is the text that I will pass. I just want to find some really cool new places, and you can see there is some sentiment also there. Here you go. You see, just terrible. So there are sentiments there. So drill, you know the drill, right? Packages, you go to the package. In this case, what do we need? Comprehend, right? So as you can see, there is a SDK comprehend. Once you have taken the dependency, now the next part is imports. Pattern is Amazon.service_name, Amazon.service_name.model, right? So in this case, the input to the API, the input to the actual comprehend API is coming via text file, and then it gives you APIs for, hey, you want to detect what is the language in that text, what are the entities mentioned there, key phrases that are there, and then sentiments. Let's quickly, for the sake of demo, let's put that comprehend as the startup project and run that. Okay, please. Okay, so it called. This is the region for which endpoint I'm referring. And for the sake of demo, I'll run the Fiddler running also. So you can see exactly the API call being made and the response coming in, right? Hopefully the demo gods are still happy. So here you go. Call the language. Okay, good. So let's see the Fiddler. Here you go. Right, that's the text. And it got language code EN. Obviously, it's in English. So, right, so let's quickly go run through this whole thing, and you can see the calls that were made. Here is the another call to comprehend. This is key phrases. It found this JSON response with key phrases. This is language code, and it found the entities, right? So as you can see, is there a sentiment? Yeah, so here is the sentiment call, and it found sentiment as negative. In the application, what I have done is basically taken that output and put that into another file. So here you go, language, en, text, it found 2021, which is type of date. These are some of the key phrases, and then negative. So we were able to use an AI service in .NET with the SDK.
Sorry to interrupt, Amit. Can
Yes.
you zoom in the Visual Studio screen and hide the the tooltip over there at the bottom?
Yeah, can you see now?
Yes.
Okay.
Can you click on hide at the at the bottom? There is a
Oh,
popping
this
up.
one you're saying. Okay. Sorry.
Yeah.
Okay. I
Thank
thought it
thank you.
needs to be there. As you can know, I am not a StreamYard user.
No issues. No issues.
Okay, cool.
Thank you.
So that's another one. Let's do another one. Just since we are here, let's do another one. So this is a translate. Again, you need the dependency. So there is SDK translate. You need the translate model, translate, right? And then again, input and then output. So it takes the same language, that text that you saw, that same thing I'm passing, and then I'm converting that same text into different locale. So call the translate. Again, another AI, auto-trained AI API available to us. You call them and you get the corresponding locale output. So set as output and call this. Okay, get the file, run it. Okay, as you can see, I got the corresponding locale generated. I am not a German Spanish, but I'm sure these are the ones that we have referred. Okay, so you'll say, okay, I got to see the resources. I got to manipulate the services via SDK. What else? Can you create, what help do you give in creating new projects? So let's do this. I'll start Visual Studio. This is again toolkit feature. I will create, use a create new project. And here there is a filter for AWS platform. Okay, so here is the AWS filter. As you can see, I have serverless templates. I have Lambda projects, right? So by default, built in, we give you starter templates. Next question is like, once I have created, what else I can do? Like, can I put it on AWS? So here is an application which I have created. This is a web application with very simple BI. It uses D3 visualization engine on the client side, right? Very simple. And Visual Studio, the toolkit actually gives you ability to do right click and publish. So you can, from Visual Studio, you can publish it to AWS. Most of the enterprise customers may not do this because they will have a CI/CD pipeline. Enterprise customers has their own DevSecOps pipelines. But this is very useful for dev test kind of use cases where you want to just quickly deploy and see how it's working or not working. You could also call the same thing via command line. We have .NET CLI extensions. You can call the same. So for the sake of demo, I have already deployed this. So let's go in and see the deployed version. Here you go. So that's the deployed version. Beanstalk is a pretty neat service. If you are getting started, manipulating EC2, auto scaling, security group is a good amount of work. Beanstalk gets you started pretty quickly, and it gives you a good health monitoring dashboard created, logs integrated. So if you haven't explored Beanstalk, it's a pretty neat service. It's like near past-like experience. So we get deployment experience also right from Visual Studio. What all things can I deploy? I can deploy Lambda functions. So here is a Lambda function, and it gives you publish to Lambda. If a Docker file is there, it gives you ability to containerize and deploy the containerized application to ECS. So we have creation, sample project types, primarily serverless oriented startup template like Lambda and serverless application. We have SDK, you saw, and SDK is both for .NET Framework as well as .NET Core 5 now, right? And you are seeing AWS Explorer, right, where you can see the resources. And it also has SSO support. So in this case, I have configured access key and secret access key, but you don't have to. We have SSO release wherein the temp credentials would work, right? And most of the enterprise customer would do that. What else? We are able to do deployment just from a testing perspective, web applications, web services, Lambda functions, all that can be deployed right from Visual Studio. And you could do the same deployment via command line using .NET CLI extensions. Okay, so those were some of the things. Oh, Amit, this is Visual Studio. Do you support any other any other IDE? You bet we do. So here is Visual Studio Code. It also has a toolkit. As you can see, here is the toolkit installed. More from a serverless application realm. It has starter templates for serverless applications. As you can see here, I can see my resources. So that's also there. Last but not the least, we also have a JetBrains slider support. So that's also exist. So now coming back to the PowerPoint. We saw SDK, sample demo, refer, call the corresponding API, and SDK does the magic. It uses the current profile connection to call the APIs, passes the HMAC signature in the list of HTTP headers, right? You saw Visual Studio Toolkit, gives you ability to see the AWS Explorer, startup templates, deployment. You saw that we have toolkit for code as well as for writer. We also have PowerShell, .NET CLI extension. Think of all the wizards that you saw, right-click is available via .NET CLI extensions. Last but not the least, we also integrate with Azure DevOps and other CI/CD tools out there. So Atlassian, Bitbucket, Shippable, Jenkins, we integrate with those. Okay, so let's move ahead here. So the same thing being shown you in the screenshots. This is a little bit of underpinnings of the SDK. As I said to you, like it actually abstracts a lot of things from you. Serialization is one of the example of it, right? As a developer, it wants you to just understand the service API. So if you're working on S3, copy, move, delete. If you're working on recognition, you want to do detect label, detect, right? So those, it wants you to focus on that, and it takes care of underlying calling, serialization, deserialization for you. Okay, similarly, it's for all the services we have a .NET SDK supported. You saw the pattern. Remember the pattern: service name model, create the client, and call the operation. Sync, async, both the way. Okay, we have it for PowerShell 2, .NET CLI extension, code, writer, and this is the writer example. I don't have the writer running on this machine. Okay. Okay, so that's one topic on the tool set and integration. Now coming to the compute. There are different compute offerings on AWS, right? As you can see from the bottom, it's EC2, which is our infrastructure service, right? It's a VM kind of thing. You move to containers, and then you move to serverless. We have both serverless containers as well as serverless functions, Lambda functions, right? How do customer take the journey? Typically, most of the customers I have seen is like, hey, on-prem, we have this configuration, CPU, memory, RAM. You map it to an instance type, they get it on AWS, and then slowly look to modernize that application. Sometimes customers want portability. Containers kind of matches to that expectation. So some customers take the containers route, and sometimes customers want to be nimble, agile, much faster. Don't want to do undifferentiated heavy lifting, right? When I say undifferentiated heavy lifting, it means, take an example. Patching a EC2 machine, does it add anything to the business? Not much. That's undifferentiated heavy lifting. So if you're here, you're doing ton of undifferentiated heavy lifting. If you're here, you're doing very least amount of undifferentiated heavy lifting, right? So this is for .NET applications. How do you map? So if you have a legacy framework-based application, these are the compute services where it maps. Pretty much options are EC2, Beanstalk, and containers. If it is .NET 5 Core, it maps to all. Kind of Lambda, Fargate, all the places. So Beanstalk, I quickly showed you. It's again underlying it's EC2, but it's like it gives you very good PaaS-like experience. If I want to show you quickly, here you go. Here is the same application that I showed you. As you can see on the left, this is the one that I love about. So it gives you by default health monitoring, scaling, alarm. That would take good amount of time if you're setting up via VM. So it gives you change history, deployment automation, very, very neat to get started. If you are looking for web applications and web services, this is definitely a service that I would recommend. You saw that. Now let's jump. We are making a jump from containers to serverless directly. Why serverless, right? Is actually anything called serverless? No. Basically, there is an underlying server. I mean, most Lambda functions underlying, there's a Linux cluster that's running, right? But you are not having access to it. So you are not doing any of those undifferentiated heavy lifting. You only pay when it's being used, right? Auto scaling in EC2, you have to configure alarms, like by what logic you want to scale up and scale down. In this case, it takes care of it, right? Very highly available and secure. And this is the one that I want to refer. Undifferentiated heavy lifting, remember? Same thing, you can map it to the operational responsibility. On the left is the most amount of operational responsibility, and the more you move towards the right, you will see. And serverless, usually people map it to the compute, but serverless is across many different places. So it can be databases, it can be storage, it can be messaging, it can be analytics. Here you see in compute, you start VM, you go to Lambda. Database, you may have RDBMS, MySQL, or others. You go to DynamoDB, our NoSQL key value pair, right? You don't work with the servers there. Similarly, storage. On the right, you go to S3. You saw we just manipulated S3. Did we manipulate any server? No. We just called an API, and we were able to upload our storage files. Messaging. Again, on the right is SQS, SNS. There is many other services in messaging, I should say, EventBridge. There's a ton of other services that are available here. Right? Again, you don't manipulate any servers. Analytics, you go to Athena. So the idea is if you want least amount of operational work or least amount of undifferentiated heavy lifting, you go towards the serverless area. Now let's introduce Lambda. It's a function as a service, run code without provisioning. So what you do is you give us a function and we take care of deploying, creating the underlying Linux cluster, deploying the runtime on which that function is dependent. So if it is .NET, obviously we need that .NET runtime. It's only for core because it's running under Linux cluster, remember. Pay only for compute time and automatically runs your code with high availability. So it takes care of spawning, scaling, depending on the request time, right? Scale with usage. So too much PowerPoint, let's go to the, I will quickly create a Lambda function via console, and then we will do it via the Visual Studio. So here is my Lambda console, right? I am gonna create a new function. There are many ways in which you can do a scratch or you can use blueprints. There are so many different blueprints available for you. There's a ton of them. Now you can actually have a container image also as an input to Lambda. Right, and there is a serverless app repository. That's again, there's good amount of apps already published, which you can learn from. So that's for the sake of this demo. I'll start with very, very rudimentary example. So today is 5/29. I'll say meetup 5/29 demo. Okay, there are many runtimes. For the sake of this demo, let's continue with Node and create this function. Hopefully the demo gods are happy. Now this time we need, for all progress bar, we should have some kind of music, right? That just makes the wait go away. Okay, so that's where we got it. Here is my Lambda function. This is my code. If I see that, it's pretty straightforward. Hello from Lambda. If I want to test it quickly, I'll say test. It doesn't need any input, so very quickly test it, and it returned hello from Lambda. Typically, people don't call Lambda directly. And you will have some kind of trigger that calls the Lambda. So let's see what triggers are there. So as you can see, the first one is API gateway. So usually there is an API gateway front, and the backend implementer is the Lambda. So it could be other things also, by the way. You see IoT device can call Lambda functions. Alexa, right? Alexa scale is nothing but a Lambda function. Smart home devices, like there's so many others, right? Think of it like database used to have a DML triggers. Now this is basically for any storage type. You can actually have a event sourcing mapped. So for the sake of demo, let's go with the standard. I will go API gateway. I will say, hey, create an API, right? HTTP API, REST API. You can have authorization. So we have service called Cognito. So you can actually have a dependency. So the JOT tokens will be validated by the API gateway. For the sake of this demo, I'll do open and added. So this creates the API gateway, and this will trigger. So let's see the details of it. Here is the details. So now this is the endpoint that I will give it to the end customer. Hey, if you take this endpoint, now I'll tell you typically what customers do. Like even if their service is hosted on EC2, they actually create an API gateway front and expose that. And slowly, the backend can be today in EC2, tomorrow it can be on containers, day after tomorrow it can be on serverless. But the end customer or the clients of that API doesn't need to know that, right? So that's a path of modernization. So we got that. Very good, Amit. But hey, this is .NET session. What are you doing here? Okay, so let's go to .NET now. Here you go. I am going to go into Visual Studio again. As you saw, there were some starter templates, right? So what I'll say is create new project. I want to use, there's something called SAM templates, serverless application model. Okay, so here is the serverless one. Okay, let it be the default name. You see, remember there it was in the console, it was start from scratch, or you want to use so similarly inside Visual Studio, this is another toolkit feature. So if you have AWS toolkit installed, you get to see this. So there are so many blueprints available. You can have a ASP.NET Core web app. So Lambda function actually. So yeah, you'll say, how does this work? I mean, I thought Lambda is only a function, right? And for the sake of demo, let's just do the core web app. Okay, so you can see exactly how ASP.NET Core web application gets served via Lambda. Okay. Okay, so the demo gods are so far happy. Thank you, demo gods. Okay, so here is the, let's do this. Let's just run it and see what this is created. It should be a standard ASP.NET Core starter template that you should see. Right, so this is our sample, but it generated certain things. Very, very interesting. Let's see here. The first thing I want to understand is dependency, right? It took dependency on amazon.lambda.asp.net core server. That's one. Second, I see some files generated here. There is a serverless template file. Looks like a CloudFormation template where it is deploying ASP.NET Core, right? It is also deploying an API. Oh, okay. So there's an API that's been created, right? So it created that. Okay. It also has two files, Lambda entry point and Lambda local entry point, right? So basically that web server trigger point happens via this. And then it has a tools default JSON. So basically configuration, like, hey, which framework version it is, which region it needs to go to, right? Where is the CloudFormation template? So that's what is the beauty of serverless application model. You'll say, Amit, you got this. Now, how do I get this on AWS? Same thing, right click, publish. And I'm taking a risk. Let's hopefully it works. So this is demo on 5/29. Let's do a publish. Okay, what happened there? Okay, for the sake of this bucket, it's on a different region. So what I did was, before coming on call, I deployed Lambda. Here you go. Just to not go into troubleshooting mode, here is the deployed web application. right? There is another example. I took another template, which is image labeling. Basically, what it means is, given image on S3 bucket, it will get triggered. The Lambda function will get triggered, and as you can see here, it uses recognition, right? So on that trigger event, it will call the recognition detect label async, and it'll find out. So this is deployed. So where do I see deployed? AWS Explorer. Go to the Lambda function and image label. Here is my image label, right? Hey, Amit, yes, I know this is the test. You could do it, but it is dependent on a bucket. So let's go in and upload a file to that bucket. Here you go. That bucket name is images 529. What I do is I'll delete this for the test sake and again upload the file. So just to show you the file, so think of it like a file is being uploaded to S3. On that upload, there is a event source mapped to Lambda function. Lambda function gets called with that new object that just got uploaded. As you can see, it's a monitor, and it will call recognition. So recognition will file attributes. So you basically, it goes and finds out like, hey, maybe there is a monitor, maybe there is some kind, and we'll see what, and each one has a confidence score. So that's the file I'm giving. Okay, and it'll populate the tags once it has the output from the recognition. So it called right now, not yet. Okay, it's work in progress. Here I can see the logs. So if I see the logs, oh, good. It made difference. See, it has home decor, monitor, electronics, display, screen, window, curtain. So if I go back to that file and see the tags, as you can see, window, what I'll do is open it again. Window, monitor, home decor, and it gives you confidence score also, by the way, right? Remember that? You saw that home decor, window, monitor, kind of maps to it, right? So that's another example of another blueprint that we used. In this case, the blueprint was for image labeling, which takes the newly uploaded file on the S3 bucket and calls the recognition with that file. And recognition gives the response of all the attributes that it is able to find and puts the tag, right? So that's another example of quick example of it. So those are some of the Lambda function examples. What does it give me? The biggest thing is if you're on EC2, you are doing so much undifferentiated heavy lifting, right? You're doing load balancing, auto scaling, handling failures, security isolation. There's good amount of undifferentiated heavy lifting that goes away, right? So here is example. There's event source type. You can write it in Node, Python, Java, C#, right? We showed you both. And this is another event sourcing architecture pattern that it enables. Most of the time, if you take legacy application, there was a synchronous based implementation. So call and wait, which doesn't scale. You want to have complete decoupling. Call, immediately come back. When it is done, it notifies. That's the pattern you want. And that's Lambda enables that beautifully, right? Think of it like the call came to the API. This went into the queue. Lambda takes it from the queue, does the processing, puts another update to the queue. Some another Lambda picks it from there, notifies via SNSE. It's completely decoupled. That's the architecture you want to go towards. Okay, so this is the core web app that you just saw. API gateway was the front, and Lambda server acted like a ASP.NET Core server. There are many different execution models for Lambda. Synchronous push, like API gateway calling the Lambda function. Asynchronous event, remember the file uploaded to S3, that called. Or it could also be a stream, poll-based implementation. There are many event sources, right? I showed you just a few examples of it, but you can have it with data sources, right? You can have it with endpoints. You can have it with configuration repositories, or you can have it with standard, what do you call? These are very useful for decoupling-based architecture, right? SNS, SQS, and Lambda becomes the integration layer across them. Okay, when do we choose Lambda over other compute offerings? There are many times people ask me, like, should I just use Lambda? It's so beautiful. Like, I don't have to do anything. Like, okay. The answer always is it depends, because your application, you may have a technical debt, you may need access to the machine, you may need to install some partner tools on there. In that case, the choice is EC2, right? So understanding the unit of scale and level of abstraction is super important, right? For EC2, we are at VM hardware level, whereas in Lambda, you're at the function runtime level. So understand that. Understand what are the use cases for which type is suitable. So if you have the need to configure, access the servers, right, then you should just not see others. It's basically EC2. And many of the legacy applications, the way they were written, the dependencies that they had, like thou shall go into a registry, change this and change. Oh, okay, come on, that's EC2, right? So that's where you go. Slowly, you look for like maybe I can containerize them. So that's when either Windows container or Linux container. You go towards ECS or EKS, right? Serverless, where most of the time what I have seen is net new applications are usually going to the serverless based architecture. Sometimes I have seen customers actually not implement the function, their business logic into the Lambda function. They actually have a wrapper in the Lambda function, and the actual implementation is in some library, so that the library itself is portable, right? So that's the pattern I have seen. Lambda and Fargate, both are available. Lambda, again, it's a short-lived, versus if you have a long running, obviously you'll go towards the Fargates. Is serverless just Lambda? Many times people make that mistake. No, it's not. There is many things, right? Data store, integrations. There is so much more to the serverless than just compute offerings. One thing I want to touch upon is the DynamoDB, which is our NoSQL key value based offering, right? It's a key value storage. It is used in Amazon itself very, very heavily. The Prime days, the Cyber Mondays, all that uses. It's a trillions of objects being manipulated at that scale performance. I mean, you can understand we actually were dependent before on Oracle, and we have completely moved to DynamoDB, our own Amazon service, right? Huge. Like whenever you have this need, I mean, RDBMS, the biggest issue was scale, right? When you have to scale significantly, it has performance, whereas DynamoDB is very suitable for the same. Let's quickly see if I have a .NET sample for DynamoDB manipulations. I think I do. Yes, here you go. So again, the drill, you get that. I have the references to the package. Here you go. And what I do here, create table and manipulate it and do some kind of operations. Let's do a debugging session on this. Okay. Okay, so I call the client. I got the client, create the table. Nice. And then do the other operations. Okay, it's waiting and checking. Okay, great. Remember, in the cloud, when you come, eventually consistent versus strongly consistent. Something will be written. It will eventually be consistent, like it will replicate to other AZs. But if you do an immediate read after write, you may not get the latest one. S3 is a classic example. Strongly consistent is basically you do it, and immediately you read, you are able to see it. So just like when you move from sync to async multi-threaded programming, and you are like whether this actually routine ran or not, you do a join or right, that kind of thing. Similarly, in the cloud, when you're manipulating by the data storage, you should know eventually consistent or strongly consistent, right? Okay, so let's go in and quickly run through this. It is doing so many operations. Let's see what the code is. Yeah, it is putting, manipulating, removing, all kinds of querying. Let's see here. There's nothing here. Let me quickly rerun it. Maybe it had a delete operation too. So I'm going to run this again. Okay, I just want to create it. Okay, and go in. Let's do few, maybe one row kind of input. Okay, now I will do a refresh. Okay, the demo gods, my machine is stuck. Okay, good, thank you. This is the table and this is the, right? So basically you create table and you start doing your key value pair based write read, right? So .NET, so Serverless, you can go from API gateway to Lambda, and Lambda can interact with DynamoDB, right? You're not doing any EC2 based architecture or VM based architectures. This is one example of one of our customer, Realtor.com. They use complete API between services. There is no backdoor entry. Nobody gets access to storage somewhere. Everybody talks over API, right? The microservices architecture actually enforces that the application or solution is net total of smaller components which can be accessed over a public API. Each API picks and chooses the right storage type based on what the data they are manipulating, right? So we saw key value. Let's say if you have a social engineering based data, you would use Neptune, right? It's a graph kind of thing. So it's basically going towards microservices essentially is breaking your big monolithic, the old applications, into a smaller set of components or services. We used to do that before also, but what used to happen was everybody used to speak to a one central storage. I don't know, SQL Server, Oracle, whatever. But then it's a dependency. If the schema change, everything broke. The idea here is each one has its own storage. Each one has its own pipeline, CI/CD pipeline. So they can continuously innovate and move faster. So we are not waiting for one release pipeline. Everyone has their own release pipeline. I already showed you some of the AI services, recognition, comprehend, translate. There are many others. We have a pretty deep machine learning stack, right? There are three kind of buckets, I can say. Frameworks and infrastructures is underlying, you have access to it. Many machine learning scientists will work on multiple frameworks. We have SageMaker. It's kind of an IDE for machine learning. So algorithm, data, training, learning, relearning, right? That's an exercise. And then there is an everyday developer who does not have the time or the bandwidth to do that model training, right? Instead, they want to have an auto-trained model and call those APIs. So these are the AI services where it has an API, you call that, and you get the output. Many customers actually, when they have an application on-prem and they can't move to a cloud, they actually just leverage AI services and they enhanced their application. Chatbots is one example. Many customers have done that. Many customers have introduced a voice interface in their applications by using the AI services. Okay, we saw the comprehend. I already showed you the demo of it. Okay, so this is the third section I'm going to go. Basically, understand the application modernization. So classic 3-tier application. Take off a bank web property. If you take on-prem, you have these servers. You move it to, let's say, AWS. We get instances. Usually start with kind of an VM-based architecture. And then we move slowly the same architecture into serverless. API gateway, Lambda as the backend, SQS, SNS basically for decoupling. So, right? So the idea here is you're continuously looking to go from a server undifferentiated heavy lifting work to complete no operations or zero operations. I mean, it's a nirvana. I'm yet to see a customer who has absolute zero ops, but you could go towards that goal, right? So this is one pattern that gets mentioned a lot, like when you have to refactor existing applications. It's called a strangler pattern. I quickly touched upon it, like you make the API as the front and back end you keep on changing. You don't have to do a big bang whole application rewrite kind of thing. You can do a smaller components change and slowly. So think of strangler. Fig tree has different branches, so you're taking each branch at a time. For .NET applications, which is legacy in nature, right? You want to understand the application. If it is a framework-based application, you want to see what it would take to actually port that application to .NET Core. We have a tool called Porting Assistant for .NET, which can do a pretty neat analysis. So here is an example of an application. It gives you a pretty detailed report of what is compatible, incompatible, what are the APIs. It actually goes to the level of source files, and it refers what you need to change if you want to take that framework application to .NET Core, right? It's an effort, but this tool helps you analyze that. We have a couple of tools in this area. One is Porting Assistant, and there is another tool called App2Container. So think of it like an application running on IIS website, be it Java, be it .NET, ASP.NET, WCF, ASMX, all kinds of web applications that used to have an IIS. It if you run this on that IS server, it will go crawl, catalog them. It will understand, it will create a container deployment package. It will create a CloudFormation template, and it will do the deployment for you on containers. So it's all wizard command line based. It crawls, understands what's there on IIS server, both for ASP.NET or .NET or Java, and then it creates the Docker image. It creates the CloudFormation template and does the deployment for. So think of it like an auto containerization based deployment. Ton of it, Amit. You have given so many things, but can you tell us resources for further reading? And here you go. We have something called well-architected framework, very neat, detailed. Go through that paper across different pillars. Cost becomes another pillar in the cloud, so very, very important to understand. We have Amazon Builders Library. Think of it like the senior principal engineers at Amazon. Amazon.com itself has gone through so much architecture journey, right? Moved from monolithic to microservices. The scale, Prime Day or Cyber Mondays, we learned a lot. So those learnings have been put into documents, and these are the documents, Amazon Builders Library. For serverless application, there's 12-factor apps design. I mean, think of it like when everything is microservices, you're calling over network. It means I need to make sure there's a rewrite, retries, right? There is a concept called exponential backoff. So you try, failed, you multiply the wait time by n, right? And then you retry. So that's some example of it. So there are some guidelines, 12-factor app guidelines. If you search, you'll get that details. Last but not the least, we have something called immersion lab, and this is basically step-by-step configuring the toolkit, deploying an application, working with DynamoDB, working with AI/ML services, working with securing, like using authentication, tracing, caching, all that CI/CD end-to-end. So definitely, as a next step, I would recommend you guys to actually go in detail, and because this is where you learn. I mean, you saw. Hopefully, I have given you kind of a tour of what support we have for .NET on AWS. But unless you actually start taking this learning and do it, it just fizzles away. So that's very important. With that, I will say thank you, and we'll open up for questions. Did I lose you guys? You're there?
Yes, we are there. That was an amazing session, Amit, and hopefully people, just got to know where they can start off and what services they can use. So for the Q&A, we have a couple of questions over there. So I'll be sharing it over the screen, and you can answer them.
Sure.
Does it work?
Yeah, definitely.
Okay. So
do I need to stop sharing?
Yep.
Okay.
Okay. So let's start with the first question. So it's from Avi. So will you publish your demo code? You did publish it before,
yes.
right?
So I already shared the. Let me just put that link, so that way you guys have that immersion day link. Can I put that in chat?
Yes, you can. I'll share it in the comment section.
Yeah. So that's the link. It's called AWS.NET Immersion Day, and it has everything. It has links to the code. It has step-by-step screenshot based. So think of it like a set of labs put together. And it may take a couple of days to actually go through end to end, but that will get you guys started very well.
Perfect. So let's move on to the next question. It's from Jose. So does AWS use TensorFlow for ML or deep learning? If not, which one AWS uses?
Oh, so as I showed you, that's a slide where we referred the AI/ML stack. We support both. I mean, and other frameworks also. I mean, we see that usually the machine learning scientists work on multiple frameworks, so we have support for both. And we also have a higher level, like let's say SageMaker Studio, which gives you end-to-end help in creating that model, training it against different set of data, learning from it, making the predictions out of it, right? And then we also have auto-trained AI services, like pre-trained models. Many of the cognitive improvement that has happened is probably I would put it there on the AI services. So explore that, and you can actually like I touched upon a little bit. I've seen customers actually add chatbots in their application for support use cases. In web applications, you would see that. Alexa skill is another one. Like many people are coming up with Alexa skill for their application. You have many voice-based interaction that you could add, like Lex and Poly. Think of it, the old applications, which was basically text-driven, right? I mean, text box and you put enter. Whereas now you could actually have a voice interface to it, right? Use the Lex and Poly, and that could very well integrate and add a new use case to your application. Hopefully that gives you some answers.
Hopefully it does. So let's move on to the next question. So it's from Olin. So he asked, what is the difference between AWS Lambdas and Azure Functions?
It's I mean, at a concept level, definitely they both have similarities, but the devil lies in the details. So when I say services are parity, there's always the details of what are the each features inside each service. That's more important. But at very high level, Azure Function also is similar to AWS Lambda. I am not here for doing any comparisons. I would want you to make that yourself. And there are several third parties who have actually done a good amount of benchmark analysis.
Hopefully it does answer, Marlin. It's more like grapes of black and green colors of they're the offerings of two different vendors. So
exactly. Yeah.
Let's move on to the next question. It's again from Jaws. So what is the difference between HTTP API and REST API?
Okay. So that's a good one. So I'll take a little bit history again here. I'll add a SOAP API also to the same set question, right? So in 1960, we had a pure HTTP definitions, right? Pure verb like get, put, post, delete. That's where we were. But people thought, hey man, that's very, very little complex. We need to abstract it. So what happened was you started creating envelope on top of it. So messaging, the layer. So SOAP layer actually born from there. You have another message. But then slowly, the SOAP layer itself became bulky, right? There's such a big SOAP payload that the request response is slow. So we went back to REST, right? So now you do again the put, get, delete, and then now it's like, hey, maybe there's more simplification, and that's where the HTTP APIs come in, right? It's a journey of how the APIs. I mean, sockets, web sockets. Remember, I mean, we used to do at the socket level, very old. If you want to do full duplex connection, so depending on your application, you would see the size of it, because now the client can be a simple camera with few MBs of memory, right? So you have to be very, very careful on what that payload is that needs to be created. Most of the enterprise customers prefer REST for security and other reasons. IoTs have integration with HTTP API, and each one will have their own. I still see SOAP-based implementations also in many FinServes, which they want to move away from, but then the WSDL and the goodness of WSDL for authentication, authorization, encoding, formatter. There are a lot of good things there, which you have to do it explicitly on the other layer. So you may have your own API layer in your application or solution. You make informed, like, should I use WebSockets? Should I use REST? Should I use HTTP API? Should I use the old based? You may have decision making to do. Most of the time in the enterprises, I have seen REST a lot.
That was really informative. I hope it does answer, Jose. So moving on to the next question, again by Jose. It's more over, when should we use Amazon Aurora or DynamoDB?
That's a good one. So RDBMS versus NoSQL. That's answers. Aurora has two engines, PostgreSQL and MySQL, right? I would say Aurora should be, should I use a commercial off-the-shelf Oracle SQL Server versus Aurora is probably a better question. And there, I mean, I would say look at performance. Look at feature, obviously. Sometimes there are some feature differences. But if you are doing standard DML-based operations, definitely explore Aurora. I'll give you one example. Aurora has serverless, multi-master, multi-region. Think of it, if you have to do that same thing in SQL Server or Oracle today, let's just say that I have something in the California and something in the New York. 2-phase commit, 3-phase commit, doing that async. Man, that's a big amount of work and hassle, right? Now you're getting serverless. multi-master, multi-region. You don't have to do anything. Why would I not choose Aurora, right? If you're doing just obviously DML-based operations. DynamoDB is key value. I mean, again, if you have to scale to huge amount of records, then DynamoDB is definitely worth exploring. There is RDBMS, and I'm not saying that you should get rid of RDBMS. There is always a case that you need that integrity, you need that ACID compliance, right? So that works in favor of RDBMS reporting. But many times what happens is because of normalization and other things, it becomes complex. Like if you have to join, do a correlated subqueries and all that, it's very, very complex. Reporting becomes hard. Scaling wise itself, like underlying, if you go to the how the Oracle or SQL Server or others store it, like segment, extents, block level, the scaling to a large amount of transactions, you have some kind of issues there. Whereas DynamoDB, I showed you some examples of Amazon itself using it in Prime Days, Cyber Mondays, and trillions of requests, like a huge level. So that's where I would say NoSQL scales better, right? But there are other storage services also. So one thing I want to say here is there is purpose-driven storage, and there is one thing that fits all. Anytime somebody says one thing fits all, you should just be aware of it, because that can never happen, right? In life also we see that nobody can be everything, and hence purpose-driven storage is the way to go. I'll give example. Time series, I have done that in SQL Server, and doing the correlated joins and all becomes hard, whereas now there is a time series offering, I would use that, right? Graph, Neptune. So when you are designing your application or microservices, look at what the data that microservices manipulates. Look at what is the right storage services for that particular data, and see what's the right service for it. Sometimes I also recommend customers, what's your NFRs, like non-functional requirement, like SLAs, right? I want 5 nines of availability. Is it after decimal? I ask to go to that level. First, you understand that. Then you look at the services SLAs or SLOs. And then you do a mapping of it. Like, is this service giving me that SLA SLO that this customer's NFR requirement is? That's also a way to explore and map the right storage services. Hopefully that gives you some answer.
I hope it does. It was quite elaborate, to be honest, and I really feel it was a really good answer. I hope it answers to you, Jose. So there was a request from Avi. It was like, can you share your slide deck?
Oh yeah, definitely. So I'll share the PDF version of the slide deck with you, Ashura, and then from wherever channels you can share that with the team.
Sure, Avi. What we can do is that Avi will be sharing the link from our Twitter handle or else our LinkedIn page, and you can get it from there. I hope that works. And now, probably it's time for a quiz.
Okay, so this is last minute I have created. Okay, let me just share the screen first.
Yeah.
Share the screen.
So guys, all the questions are related to this session. So, a few lucky ones can actually get some AWS credits to, play around, explore the services.
Okay, so I'm starting the Kahoot. What you need to do is go to something called kahoot.it. Kahoot.it, Kahoot.it. Once you go there, it'll ask you a pin. And if you see the screen, you should see the pin. The pin is 6349284. It'll ask you for a nickname. Just be prudent and put the right good nicknames. Once you put that, I think I should be able to see you joining the.
Probably you can enter your email address. It will help us, share the coupons with you later. So we have one, Jim. Okay, Amit, can you share the link over in the private chat? I can share it in the comment
Yeah,
section.
it's kahoot.it. So let me go here, and it's kahoot.it. That's the one.
Cool. Thank you.
If not, we'll make Jim the winner. How about that?
Sounds good.
Okay, I see Andre joining in.
Well, guys, you are going to get some free credits
No
over here.
judgment here, so please feel free to join. There is no judgment here. That's absolutely not the intent. The intent is to have a little bit of fun. Okay, I'll get started with the two folks. So AWS.NET Tools, AWS.NET Serverless, AWS Toolkit for Visual Studio provides. Does it provide Explorer, project starter templates, deployment wizards, or all of the above? Is it Explorer, starter templates, deployment wizards, or all of the above? You get 20 seconds. So you will see a corresponding shine in your good. So one guy got it right. So I know sometimes what happens is Kahoot itself is news to folks. And so you will see 4 different shapes. You see the corresponding answer and you click on that shape. You get, the faster you respond, the more points you get. Okay. So I can understand this can be a mistake for the first time use. Jim, congratulations. Let's go. Next, Legacy.NET Framework app can be run hosted on. Can you run Legacy.NET Framework on EC2 only, EC2 Beanstalk ECS, Elastic Beanstalk only? Will need refactoring. Where can you host? EC2 only, Beanstalk only, EC2 Beanstalk ECS, or it will need refactoring? Perfect. That's the answer. EC2, Elastic Beanstalk, and ECS. Framework-based application needs Windows containers. That's why ECS. Unless you make that .NET Framework to .NET Core-based application, you don't have the choice of serverless. Moving to next, Jim is still leading, and Andre is behind. ASP.NET Core app can, so now it's Core. Core can run only on Lambda, can run on EC2, ECS, Beanstalk, can run on EC2, ECS, EKS, Fargate, Beanstalk, Lambda, or EC2 only.
Probably all of the ones.
Exactly. It can run on all of the one. That's the answer. Hopefully people got it. I think Jim or Andre. Oh yeah, all 3. Awesome.
This is gonna be a tough fight.
Jim is leading. Andre is not behind. What is the CFN file name generated for deployment by VS? CFN file name. So in the Lambda one, you saw that, right? I was running through it. Serverless template, Lambda template, CFN template. What was the file name? Remember, I deployed a ASP.NET Core serverless application model. I showed you the CloudFormation template, showed you the API. Perfect. Thank you for paying attention. You guys are awesome. Thanks a lot. Serverless template. Okay, so man, there is a last minute change here. Congratulations, Andre. You are the winner. Jim, you are not that far behind. This is a luck question, 5th one. Oh, actually, no, not luck one. Okay. For key value storage, which AWS storage service is appropriate to use? Is it AWS Dynamo? Is it AWS DynamoDB? Is it MongoDB? Or is it RDBMS? For key value storage.
DynamoDB?
Exactly. Then, thank you. Somebody got into that trap. Dynamo. I created it like 5 minutes before coming into the call, so I'm sorry if it was not very explicitly clear.
This was tricky indeed.
I know. So here you go. 3rd is Bhavesh. Congratulations, Bhavesh. And 2nd is Andre. Okay, he went back, and Jim has been the leader from the start. So I think Jim is the winner. Congratulations, Jim.
Congratulations, Jim. So, Jim and Andre, can you share your email ID in the comment section? It will help us to reach you out.
yeah, I can share the code with you guys.
Probably let's rope in Bhavesh too. He too gave a good fight.
Yeah, I think not a bad idea. Bhavesh, please put in your email ID too.
Yep. And there's a feedback form, guys. So do fill in your feedback forms.
So share your
And
email ID, guys. I see somebody asking, like, should I share my email here? Yeah, you can share it, Andre. Andre, Jim, and Bhavesh, please put your email
Bhavesh.
ID. I will share AWS credits with you guys. Thank you.
Perfect. So let's wait for Bhavesh and James. Okay. Thank you, James. Okay, Bhavesh, you're missing out.
Bhavesh doesn't want it. I think he's a very, very good person. No freebies. Bhavesh, if you want, you can put your email. If not, it's okay.
And guys, those who didn't get, the credits this time around, you can definitely get one from the feedback forms. 5 persons who, actually have submitted the feedbacks are going to get it. It's going to be completely randomly decided. There's no hard and fast rule. So submit it, just give your luck a shot. So what I'll do is that I'll just show it in the banner again. Maybe it'll help you folks just submit your feedback if you haven't yet. Okay. So in the meanwhile, this is the feedback form. You folks can go and, this is the link where you can just submit it. And since there is a field, to mention your email address, I can just pick your email address and share it with you after the session. Let's wait for a minute. Okay, in the meanwhile, there are a few questions that remain unanswered. Actually, it came up during the Q&A. So with your permission, can I share it with you?
Yeah, please.
Okay. So the question was, which option of CraftDB in AWS I chose?
Neptune.
Very good answer. By the way, Jose, we do have one, one credit for you because you have been asking a lot of questions and you kept the whole session, engaging. So please share your email ID. We are open to sharing one credit with you, credit voucher with you. So please share your email address. We'd love to share one with you. The next is from Molin. So he's asking, suppose I want to move message forwarding, can we use RabbitMQ instead of AWS SQS when deploying applications using EKS?
Okay, you got me there. I will have to actually, as you know, I don't know everything. Obviously, this is one of it. I'll have to get back to Ashirvad on this one. I would guess yes, but I'll confirm with you.
Sure, that works. I hope it does work with you too, Marlon. Probably we'll answer it from one of our posts later from our channels. So I hope you folks have already submitted the feedback forms and dropped your email addresses. Just please do drop your email address. So do Bhavesh, You shouldn't be missing out on these credits. It's fun to explore and play around without costing you a single penny. So this is about our next upcoming event. So it's on operating container apps with AWS Copilot. So the demo will be based on AWS Fargate. If you people are interested in container solutions or are deploying containerized applications, I think you people will be really interested with that. So it's on 19 June 2021. That's the link where you can just go and register. So that's about the next event. We have a lot more events coming up. I tell you, the events that we missed in the last 2 months, we are going to cover up in the coming months. So these are the informations about the the very next event that we are going to have. And apart from that, okay, Bhavesh did submit his mail IDs. Thank you, Bhavesh. Okay, So apart from that, we'll be announcing the results of the lucky winners who won the credits from the feedback forms. We'll be sharing it in our Twitter handle. So do keep a note of that. So this is a Twitter handle. So you can get more information over there. If you do have any queries, just drop us a mail. Drop us a DM over there. Or else if you want to host a session sometime around, we are open to have you on board as a speaker. So do let us know. We are a very open community. We encourage you folks to join in and host a session. And that's all from our end.
Can I do a shameless plug? If you can share my Twitter handle with the folks,
Sure.
I keep sharing some resources there also.
So just give me a moment. I'll do that.
Thank you.
Just a minute. Okay, so this is Amit's handle. So you can just follow him over there. Just zoom in for you folks to see his username. So I'll just type it out. So you can follow Amit. This is his Twitter handle. So you can search over Twitter using his handle. And let's do a self-promotion for myself too.
Thank you. Thanks.
Yeah, you're welcome. You're welcome, Amit. So this is mine. Do keep do follow if you want to keep notified about future events. So there's one more event that we are co-organizing with another developer community called UTF. So it's specifically about Blazor. So you are a .NET guy and you never had a freedom to make spas or PWAs using C# or Razor syntaxes. This is the time for you. You have Blazor to build such applications. So we are organizing an event called BlazorConf Bhubaneswar. So I'm just share it with you folks. So do join in if you are interested. Okay, just give me a moment. Sorry. Okay. Okay, just give me a moment. In the meanwhile, if you have any questions, do just shoot it out in the comment section, and we have Amit for 2 or 3 more minutes to answer your questions. In case, Amit, you want to share something, you can also share with the folks.
One thing I'll share in the journey that I have been on the cloud since last 4.5 years. Initially, it was daunting. Like basically, I felt uncomfortable in not knowing many services. But then, if you become comfortable at not knowing those, it's okay. I mean, nobody can know 180 plus services and the features of it, but not just high level, but also the detailed features. It's better to actually look at the solution or the business problem that you're trying to solve and look at the services that makes the most sense for that business problem and learn those and just iterate on the same thing. There is no need to learn all the services. That's just the wrong path I took initially. I would rather want people not to take that path and build things. Building is the best way of learning.
Learn by doing. Thank you, Amit. Thank you for sharing your experience. And I have the website with me now. So cool. Here it is.
Thank you, Jose. Thanks for sharing your feedback.
Thank you, mate. So this is the website. So we have a couple of sessions lined up. One is on Trailblazer. There's a session on building mobile and desktop apps with Blazor. There are many things. If you folks are following Microsoft Azure, then you must be aware of static web apps. So we have a session on that. Then there's one session on unit testing. There's one on components, forms, and validation. So this is a bit of a self-promotion. I'm going to host a talk. So, and again, we have some great coupons and takeaways over there. So do join in. And we have a good line of speakers. So there's Sean, who was a founder of .NET Nukes. There's Stacy, Egil, Michael, Sam, Ravi, and me. So it's an exciting lineup of speakers, and there are some great sessions there, for you to enjoy and learn. So do join in for that too. And thank you everyone for joining in. Have a great day, and hopefully you'll be getting your credit soon. So thank you.
Yes, I noted the 3 emails. I'll make sure I send them right away. Thanks, Ashirwad, for hosting this. Enjoyed. Hopefully, this was a good, worth the time for the folks who attended. Look forward to doing many more of these.
Definitely. Looking forward to have you in one of our future sessions.
Will do.
Thank you, Forrest. Signing off.